Addition and subtraction with rational expressions is a little trickier because it requires the use of a common denominator. Let me give you a numerical example before I go through this algebraic one, just to remind you how it works. If I need to combine the fraction 5/7 and maybe I want to subtract, let's say, 2/3. All right. Well, in order to do the subtraction, both denominators have to be identical. Because you're just trying to compare equal parts of part to whole with the numerator and the denominator. So in order to do the addition or the subtraction, you got to change both denominators so that they are identical. So I'm going to draw two more fractions over here, and the common denominator is going to be the least common multiple of 7 and 3. The least common multiple of those two is 21. And then you want to compare to the original fraction. To get 7 to go into 21, I had to multiply the bottom by 3. So since I had to multiply the bottom of this fraction by 3, I got to multiply the top of the old fraction by 3 as well. Technically, this is the number 1. So when I multiply the top and the bottom by the same value, I'm not changing 5/7 value itself, but I am changing it into a form where it can become added and subtracted with another fraction. So that becomes 15 over 21 in the new fraction. Same idea with this one. To get this denominator to become a 21, I had to multiply the bottom by 7. So you got to multiply the old numerator by 7 as well. So the top 2 gets multiplied by 7 and becomes 14. So this is still the same calculation. This is still 5/7 minus 2/3. I've just rewritten them as equivalent fractions so that they have matching denominators. And then you can just subtract across the top. 15 minus 14 is 1. And then the whole unit for the fraction, the denominator, is 21. So 15 parts of 21 minus 14 parts of 21 is 1 part of 21. Okay, so that's the numerical version of this that you have done in arithmetic. Now you need to review doing it with algebra because it's probably been a while. You still need to change both denominators so that they match up. The way you find the least common denominator here is you just essentially take every unique factor, x minus 6 and x plus 2, and find their least common multiple by multiplying them together. So x minus 6 and x plus 2, since they are unique factors, they don't share any powers in common, that means I'm just going to go ahead and flat out multiply them together to get my new common denominator I need for the transformed fractions. So then compare the new fractions to the ones they came from. This first fraction already had the x minus 6 in the bottom. Since I had to multiply the bottom by x plus 2, I've got to multiply the old numerator times x plus 2 as well. So here's like what I've got written here in red. This is the clever form of the number 1 that I had to multiply this original fraction by in order for it to get this common denominator. From this fraction to this one, the x plus 2 is already there, so since I had to multiply the bottom by x minus 6, I got to multiply the old numerator by x minus 6 as well. Okay, so I'm in the process of bringing these two fractions together, so I'm going to go ahead and anticipate one big fraction bar with my common denominator underneath, and then we'll start just distributing and collecting like terms when I add across the top. So now that they have matching denominators, this numerator of x squared plus 2x can eventually add with this numerator of 5x minus 30 to give me x squared plus 7x minus 30 over that common denominator, x minus 6 times x plus 2. Now, when you're finished, you want to make sure that the final fraction is actually reduced into lowest terms. So that goes back to the first example we did with rational expressions, where you completely factor your numerator and denominator to see if there are any common factors that they have. Notice this numerator is an AC method problem. It might be able to factor, let's see, two numbers. Okay, I would need positive 10 and negative 3. So I can factor the top as x plus 10 times x minus 3. My denominator is x minus 6 and x plus 2. Well, so even though I could factor the numerator, there's no actual factors that'll reduce here. So since I can't reduce it and simplify it any further, either one of these are acceptable answers. So I'll put the word or here, because either this answer or this answer would be acceptable because they are algebraically equivalent, since the fraction can't reduce any further. So you see, addition and subtraction are a little bit more involved because you have to get matching denominators before you can actually do the addition or the subtraction. Let me show you a subtraction example that involves three fractions. It says to add and subtract. It looks like, well, technically this is a positive fraction, so it's being added. The other two are being subtracted. But same idea. We still need to make sure we have a common denominator before we can actually bring all these three fractions together. So it looks like x plus 2 and x minus 3 will have to be parts of our common denominator, because just right off the bat, that's two factors I see, two unique factors in two different denominators that I see we're going to need to accommodate. So x plus 2 and x minus 3 will be part of the LCD, least common denominator. This trinomial here, you got to factor it to see if there's any other factors that you need to contribute to the denominator you're making. So that's going to be x minus 3 and x plus 2. And since that factors as the same two factors we've already got, that means this is our full correct LCD. So I need to transform all three of these fractions so that they have a denominator that looks like x plus 2 times x minus 3. So let's make three fractions that have those denominators, and then minus, change the middle fraction, and then another minus, and our third fraction. And let's see what changes they need to go through. The first fraction already has both of these factors in the bottom, so it goes through no change whatsoever. It will stay just an x in the numerator. It's the two fractions that are being subtracted that have to be changed. The middle fraction is missing the x minus 3, so I need to multiply the numerator of 1 times x minus 3. And this fraction, the third one going to here, is missing the x plus 2, so I need to multiply the old numerator of 2 times x plus 2. Okay, so now when I'm bringing these together, I'm going to try to bring these into one fraction so that they have that common denominator. The first numerator is still going to stay x. Now what you got to be careful of is this. When you're subtracting fractions, you got to make sure you apply the minus to both terms, or all the terms that are in the following numerator. See, this is going to be a numerator of x minus 3, but since it's being subtracted, that's going to become minus x plus 3. So watch out for that sign change. That'll always occur whenever you're subtracting a numerator. Same with this one. This minus sign is going to influence these two signs that you get. See, this numerator is going to be 2x plus 4 when you distribute it out. So since it's being subtracted, to bring it down here, that's actually going to need to be a negative 2x minus 4, because of the same sign changes that occur. So we've built our single fraction. That's one of the major goals of the problem, is to bring them all into one fraction. Let's collect our like terms together. You're going to have these x's canceling out with subtraction, x minus x. 3 minus 2x minus 4, those are going to simplify to negative 2x minus 1. And my common denominator is still there. And since there's no more factoring I can do to reduce that, that should be the final answer, the final combined result of that subtraction. So I'll circle that as my final answer. The only alternative, I think, is if you wanted to factor a negative out, you could, but it's not necessary. You can just, since there's nothing that's going to cancel after you factor out the negative, there's no real need to do it. All right. So one more video I need to show you, and then this will wrap up the lesson on rational expressions. So I'll get to it here shortly.